There is something fundamentally wrong with how physicists talk about time. Not wrong in the way a theory is wrong when new evidence arrives. Wrong in the way a person is wrong when they stand in front of a mirror and describe themselves as beautiful, while their hands tremor and their eyes are darting everywhere except at their reflection. They know. They have always known. But the machinery of modern science is not equipped to admit certain truths once they become too uncomfortable, once they require not just a new equation but a new way of existing. Let me start where the story actually begins, not where the textbooks want you to think it begins. For 300 years, physicists operated under a single assumption so obvious it did not need to be stated. Time was the stage. Space was the stage. Reality was the actors moving across these twin stages in a predetermined direction that everyone could see and nobody questioned. Newton drew his equations, and time flowed in them like water downhill. Reliable, directional, real. Newton's universe was a universe where time was absolute. It was the same for everyone, everywhere. A clock in London and a clock in Beijing would tick at exactly the same rate, measuring the same moments in the same sequence. This was not something Newton felt he needed to justify. It was just obviously true. And for 200 years, this view went unchallenged. It was the foundation of physics. It was the assumption that made everything else possible. But beneath this certainty, there were cracks. There were problems that physicists noticed but could not quite solve. There was the question of simultaneity. If an event happens in London at the same time as an event in Beijing, what does that mean? What does same time even mean when London and Beijing are separated by thousands of miles? Newton said it meant the same position in the absolute flow of time. But how would you know? How would you ever verify that two distant events really are simultaneous? You would need to compare clocks, but the signals that compare the clocks take time to travel. So you can never know with absolute certainty that two distant events are truly simultaneous. This is not a practical problem for everyday life. But it is a theoretical problem. It is a crack in the foundation. And physicists of the 18th and 19th centuries knew about this crack. They just did not know what to do about it. So they ignored it. Then, in 1905 and beyond, Einstein came along and did something that should have sent alarm bells through the entire scientific world. He took that crack and followed it all the way down. He said that simultaneity is not absolute. He said that the question, are two distant events simultaneous, does not have a well-defined answer independent of who is asking the question. He said that observers in different reference frames will disagree about which events are simultaneous. They will disagree about what is happening right now in distant places. And he said that this is not a limitation of our knowledge, this is a feature of reality itself. Simultaneity is relative. From this single insight, everything followed. If simultaneity is relative, then time cannot be absolute. Different observers must measure time differently. A clock moving through space must tick slower than a clock at rest. Time must be relative. And if time is relative, if it depends on the observer's motion and position, then time cannot be the absolute privileged dimension that Newton thought it was. Time must be something more like space. Time must be a dimension. So Einstein married space and time together. He said they were not separate things but two aspects of the same thing. Space-time. A unified geometric structure. This was presented as an unification, a simplification, a triumph of human understanding. And it was. Except for one small detail that almost nobody has ever acknowledged properly. The moment you unify space and time into space-time, something very strange happens to time. It becomes spatial. It stops being different from the other three dimensions in any fundamental way. Oh, sure, there are technical differences. The metric signature is different. There is a minus sign in the math where space has plus signs. But structurally, mathematically, geometrically, once you put time on the same footing as space, time becomes a dimension, Dimensions do not flow. Dimensions do not pass. Dimensions simply exist. They are the stage. Einstein never said this out loud to the popular press because he was more careful about these things than modern physicists are. But look at what he wrote in his technical papers. Look at what he drew in his diagrams. The universe is a four-dimensional object. Past, present, and future are not becoming. They are not flowing into each other like sand through an hourglass. They are coordinates. The same way the distance between New York and Boston is a fixed coordinate on Earth. The distance between your 10th birthday and your 40th birthday is a fixed coordinate in space-time. Your 10th birthday is not gone. It is not destroyed. It is not traveling backward into some void. It is simply located at a different coordinate than the coordinate you currently occupy. That is it. That is all that special relativity demands. And that was 1905. That was already more than 100 years ago. Now, before we go forward with this, I need to tell you something about what happened between 1905 and 1967. Something that is crucial to understanding why physicists have been so reluctant to confront the implications of relativity. There was another problem with time. Another dimension of this issue that made physicists even more uncomfortable than relativity did. The problem was called the arrow of time. It came from thermodynamics. In the 19th century, physicists had discovered the second law of thermodynamics. Entropy always increases. A closed system always tends toward greater disorder. Heat flows from hot to cold, not the reverse. Broken eggs do not reassemble themselves. Spilled milk does not jump back into the glass. Time has a direction. Time has an arrow. And that arrow is the direction in which entropy increases. This seemed obvious. This seemed to match experience perfectly. Time flows from past to future, and in that direction, entropy increases. But here was the problem that physicists realized immediately and have never really solved. The fundamental laws of physics do not care about entropy. The laws of mechanics, the laws that Newton and Einstein wrote down, are reversible. If you reverse time in Newton's equations, they still work. If you reverse time in Einstein's field equations, they still work. The fundamental laws do not have an arrow. They do not care which direction time is pointing. So where does the arrow come from? How can the fundamental laws be reversible when experience shows that time has a preferred direction? How can the microscopic laws be symmetric in time when the macroscopic world is not? The answer that thermodynamics provides is statistics. The arrow of time is not a fundamental feature of the laws. The arrow of time is a statistical feature of the initial conditions of the universe. The universe started in a state of very low entropy, and it is evolving toward a state of higher entropy. We always observe time flowing from low entropy to high entropy, because that is the only direction in which the universe is actually moving, given the way it started. But this raises a question that physicists have been uncomfortable asking out loud. Why did the universe start in a state of low entropy? Why was the initial condition of the universe so special, so ordered, so unlikely? If entropy always increases, if the universe is always moving toward disorder, then the fact that the universe started in an ordered state is a puzzle. It is a puzzle that nobody has solved. It is a puzzle that makes the whole story of entropy and the arrow of time feel like it is incomplete. This is the thing physicists do not like to discuss. The second law of thermodynamics, which seems to give time a direction, which seems to prove that time flows, is built on an assumption that the universe started in a special ordered state. But physics cannot explain why the universe has this initial condition. Physics can only accept it as a given. And that feels wrong. That feels like physics is just pushing the mystery further back, not solving it. So by the time Einstein had unified space and time, physicists were already troubled by two different problems with time. On the one hand, relativity was suggesting that time is a dimension, that time is not fundamentally different from space, that the block universe might be real. On the other hand, thermodynamics was saying that time has a direction, that the universe flows from past to future, that the initial conditions of the universe are mysteriously special and ordered. These two pictures do not fit together easily. And physicists have spent more than 100 years trying not to think about this contradiction. But Einstein understood something that physicists after him kept trying to forget. If time is a dimension, then time is not moving. If time is not moving, then the distinction between past and future becomes arbitrary, perspective-dependent, observer-relative. He was already circling the drain of what his own equations were telling him. When he moved from special relativity to general relativity, when he incorporated gravity as the curvature of space-time itself, the problem became even worse. The equations of general relativity make no reference to the present moment. They do not care which direction time is pointing. If you reverse time in Einstein's field equations, they work exactly the same way. They solve exactly the same. The mathematics does not have an arrow. The mathematics does not care whether a light cone points forward or backward. So physicists did what physicists do when confronted with a result they do not like. They looked away. They said the math is describing something static, something timeless, and they moved on to other problems. They did not say it out loud. They just kept working as though time was still flowing, even though their own equations did not require it and did not support it. This worked fine for a while. Relativity was weird enough without adding time does not exist to the conversation. People could accept curved space and time dilation in black holes, because these were just adjustments to how time worked. They did not challenge whether time worked at all. Then came 1967. Then came Wheeler and DeWitt. John Wheeler was one of the most brilliant physicists of the 20th century. Bryce DeWitt was equally formidable. They were trying to do something that everyone agreed needed to be done eventually. They were trying to write down the equations that describe the entire universe, not a particle in a field, not a galaxy spinning through space, the entire cosmos, all at once as a single quantum system. Because if quantum mechanics is fundamental, and general relativity is fundamental, then the universe itself must be described by quantum mechanics. There is no outside observer, there is no external clock. The universe is all there is. So what does the mathematics look like? Wheeler and DeWitt wrote it down. It is called the Wheeler DeWitt equation. And when they stared at what they had written, they saw something that should have been announced from the rooftops of every university on Earth. The equation has no time variable in it. This is not a metaphorical statement. This is not a poetic observation. This is a literal, technical, mathematical fact. The Hamiltonian operator, the thing that in all other quantum systems represents energy and drives change over time, acts on the wave function of the universe and produces zero. Nothing. Zero. The equation says that the universe does not change. The universe does not evolve. The universe does not have a clock. The universe is static. Now, you might think this would be treated as the most important discovery in modern physics. The equation that describes the entire universe has revealed something fundamental about the nature of reality. The universe itself is timeless. This should have been everywhere. This should have been in every newspaper. This should have been the subject of 1,000 books explaining what it means for human beings to understand that time, as they experience it, is not a feature of reality but something else entirely. Instead, the response from the physics community was bureaucratic. It was institutional. It was the response of an establishment that has already decided what reality should look like and is now faced with mathematical evidence that it was wrong. The response was to fix the problem. Not the problem of understanding what the equation was telling us, the problem of the equation not having time in it. Physicists invented workarounds. They introduced auxiliary variables from scalar fields, pretending these were clocks ticking through the quantum evolution of the universe. They created something called the WKB approximation, and said that in the semi-classical limit, time emerges as an effective description. This is true, by the way. In that limit, time does emerge, but emergence is not the same as fundamental. Emergence is what happens when you approximate, when you ignore details, when you step back far enough that something looks simple. It is like saying that a table emerges from atoms. Yes, technically true. But the atoms do not care about the table. The table is a useful description for beings that are much larger than atoms. The table is not real in the way atoms are real. Time, according to the emerging consensus among physicists willing to think about this at all, is the table. Not the atoms. You are the atoms. The universe is the atoms. And time is a useful story that emerges when you get far enough away from the fundamental equations that you can stop paying attention to them. Do you understand what they were doing? They were admitting defeat while pretending to win. They were saying, yes, the fundamental equations have no time. But do not worry, we can make time appear if we squint hard enough and ignore enough details. Do not worry about what the universe actually is. Focus on what it looks like from your perspective. Focus on how it appears to your consciousness. Do not ask what is really happening in the Wheeler DeWitt universe, because the answer is that nothing is happening. Everything has already happened. Or nothing ever happened. The distinction collapses. And into this void of discomfort and denial stepped a man named Julian Barbour. Barbour is, in many ways, the exact opposite of what a modern physicist is supposed to be. He earned his doctorate in relativity and gravitation in 1968. And then, instead of climbing the ladder in some prestigious department, instead of playing the game of grant proposals and committee meetings and polite disagreements with competitors in the same field, he walked away. He worked as a translator of Russian physics papers, translating from home, supporting his family, and spending his actual time on physics that he thought was true rather than physics that would impress his colleagues. This is not a path that modern academia particularly rewards. In fact, modern academia treats this path as a kind of professional suicide. If you are not at a university, if you do not have access to the institutional apparatus, if you cannot point to a department and a salary and students depending on you to maintain your credentials, then you are not quite serious. You are a hobbyist. You are a crank. Even if what you are saying is right, especially if what you are saying is right, you will be treated as someone operating at the margins. And what Barbour was saying, what he has been saying for decades, is so simple that it seems absurd when you first hear it. Time does not exist. Not as a flow, not as a river, not as an arrow pointing in a particular direction. What we call time is something else entirely. It is our experience of change. And change, Barbour argues, does not require any underlying time dimension at all. Change can happen without time. Two configurations of the universe can be different from each other without one of them being earlier than the other, without one of them coming before the other in time. Imagine the universe as a vast, infinite collection of configurations. Every possible arrangement of every atom, every photon, every particle, every quantum field, every star, every black hole, every neuron in every brain that has ever existed. Each of these configurations is complete. Each is self-contained. Each is absolutely still. There is no motion in them. They are frozen snapshots of what the universe looks like at a particular instant. But here is the key part. There is no instant, there is no moment, there is no now. There are just these configurations, existing in some mathematical or metaphysical space that Barbour calls Platonia. Your life is not a movie that is playing. It is not a sequence of frames being displayed one after another. Your life is something stranger. Your life is a path through Platonia. Imagine it like this. Imagine all possible chessboard positions stacked in a vast space. A chess game is not something that happens. A chess game is a path through that space. The first move creates a new board position, connected to the starting position. The second move connects to the third, and so on. The game is the path. The game is the sequence of positions. But the positions do not cause each other to happen. They are simply connected. They form a structure. The game is the structure. Your life is like that. There is the configuration of you being born. There is the configuration of you at age 5. There is the configuration of you reading these words right now. There is the configuration of you dying. These are not happening in sequence, they are not unfolding. They simply are. They exist in Platonia. And the reason you experience them as a sequence, the reason you have the feeling that time is passing, the reason you remember the past and are curious about the future, is something entirely different. It is not because time is passing. It is because you are a particular kind of physical system. You are a system that stores information. You have memories. You have anticipations. And these memories and anticipations create a sense of directionality, a sense of before and after, even though in Platonia there is no before and after. Think about what this means. The version of you that is currently reading these words is not arriving at this moment. The version of you is not being created right now. The version of you reading these words has always existed in exactly the configuration it is in right now, forever. The same is true for every version of you that has ever existed. The version of you eating breakfast this morning, that still exists. The version of you at your first birthday, that still exists, frozen, untouched, exactly as it was. The version of you on your deathbed, that still exists too. None of these are happening. None of them are occurring in sequence. They are just there. All of them, together, in Platonia. When people first hear this, they want to dismiss it. They want to say that Barbour is a fringe thinker, that he is operating at the edges of physics where serious scientists do not venture. They want to say that just because one man refuses to play the game does not mean the game is wrong. So I want to stop here and remind you of something that every physicist knows, but almost none of them say out loud. Albert Einstein died in 1955. By that point, he had spent more than 50 years thinking about the nature of time and relativity more carefully than almost anyone who has ever lived. On March 15th of that year, just a few weeks before his death, Einstein wrote a letter to Michel Besso's family. Besso was one of Einstein's closest friends and colleagues. He had just died, and Einstein, who was himself dying, wrote to his family about what had happened. He told them that Besso had not really gone anywhere, and he used a specific phrase to describe this. He said, nearly word for word, "Now he has departed from this strange world a little ahead of me. That signifies nothing." For us believing physicists, the distinction between the past, present, and future is only a stubbornly persistent illusion. Read that sentence again. Let that sink in. Einstein was not being poetic. He was not trying to comfort a grieving family with beautiful metaphors. He was writing to them about the literal structure of reality as understood by anyone who takes relativity seriously. Besso was not gone. He had not ceased to exist. He had simply moved to a different coordinate in the four-dimensional manifold of spacetime. He was still there, in that coordinate, forever, just as every moment of Besso's life was still there. Birth, childhood, his meetings with Einstein, his final moment, all of it still existing in the block of spacetime, untouched and unchanging. And here is the part that makes you understand how serious all of this is. That letter has been quoted in physics seminars and graduate programs for 70 years. It has been discussed in quiet conversations at conferences. It has been carefully preserved and studied by historians of physics, and almost none of it has made it into the public consciousness. Why? Why would one of the most important statements ever made about the nature of time, by the man who fundamentally changed how we think about time, be essentially hidden? Why is it not taught in high schools? Why is it not the subject of documentaries? Why is it not the opening scene of every physics textbook? The answer is that the physics establishment has decided, collectively and without any formal vote or decision, that the public cannot handle this information, that we are not ready for it, that the world functions better if most people keep believing that time is flowing, that the past is gone, that the future is open, that the present moment is special and real in a way that other moments are not, that our choices matter in the way we intuitively think they matter, that something we do right now can change what happens next because the next moment has not happened yet. The block universe is the standard interpretation of general relativity. It is taught in graduate programs. Every serious physicist has encountered it. Most of them believe it, or at least believe that the mathematics requires it, even if they do not like to think about the implications. But there is an agreement, unspoken but real, not to make a big deal about it, not to explain to the general public what the equations actually seem to be saying, not to admit what Einstein knew when he was dying. So what does the block universe actually look like? Picture the entire history of the cosmos laid out as a single four-dimensional object. 3 dimensions of space, the way you experience it, left and right, forward and backward, up and down. And 1 dimension of time, running from whatever moment physicists decide is the beginning of the universe to whatever moment physicists decide is the end. All of this welded together into a single structure that simply exists: past, present, future. These are not states of the block. They are not things that the block goes through. They are locations in the block. Imagine standing outside of this 4-dimensional block, looking at it the way a sculptor looks at a finished marble sculpture. You would see something that sounds peaceful but turns out to be deeply unsettling. You would see the entire history of everything simultaneously. You would see the formation of galaxies and the birth of stars and the collision of black holes. You would see the formation of Earth and the emergence of life and the development of human civilization and all of human history compressed into the sculpture. And you would see it all at once, all of it equally real, all of it equally present, all of it equally frozen. The key insight, the thing that makes people uncomfortable when they really sit with it, is this. If you move your perspective to the right in the block, if you move along the time direction, the way you move along space by traveling from New York to Tokyo, you are not watching the universe change. You are not watching reality evolve. You are simply changing which part of the sculpture you are looking at. When you travel from New York to Tokyo, we do not say that New York has ceased to exist. We do not say that Tokyo is being created as you move toward it. We understand that both places exist, and moving from one to the other just changes your location. The block universe says exactly the same thing about your past and your future. Your past still exists. It is still real. It has not been destroyed. You have simply moved away from it. This is not Barbour's invention. This is the standard interpretation of Einstein's relativity that physicists learn in graduate school. The block universe is not a fringe idea. It is the mainstream interpretation. It is the thing that the equations point to. It is what you get when you take relativity seriously and do not add any additional assumptions or complications. It is just what general relativity says when you ask it what the universe actually is. The uncomfortable part comes when you start asking what this means. If the block universe is real, and the equations of general relativity seem to demand that it is, then your future is not open. Your future is not unwritten. Your future is not something that is being decided right now by your choices. Your future is already there. It exists. It is as real and as fixed as the room you are sitting in right now. Every conversation you will have next week, the exact words that will be exchanged, the tone of voice, the pauses, the way someone will smile or frown, all of it is already sitting in the block in the future region of space-time, waiting for you to move toward it. The meal you will eat tomorrow is already configured exactly as it will taste in tomorrow's region of the block. The person you will or will not fall in love with, whether that love will last, whether it will break your heart or heal a wound in your soul, all of that is already fixed in the block. The day you will die, if you are going to read these words and then go about your life for 40 years before a moment of sudden illness catches you, that moment is already there. The year it will happen, the month, the exact configuration of the room you will be in, the people who will be holding your hand, or the fact that you will be alone. All of it is already written into the geometry of space-time. And here is where the problem becomes not just philosophical, but existential. Free will becomes not just questionable, but literally impossible. The experience you have of making a choice, of weighing two options, of deliberating, of deciding, that experience is real. You do have that experience. But if the block is real, then you are not actually choosing between two real futures. You never were. The future you experience as one of two possibilities is already determined. The past and future both exist in the same way. Nothing you do in the present changes either of them, because the present is not the only real time anymore. All times are equally real. This is where people usually get stuck. They say, but I feel like I have choices. I feel like my decisions matter. And the block universe does not deny that feeling. It just says that the feeling is not enough. The feeling is a feature of your particular physical configuration. Your brain stores memories. Your brain models the future. Your brain creates the experience of deliberation and choice. But the deliberation does not change the outcome. The outcome was always going to be what it was. The deliberation is part of the block, just like everything else. It is frozen in place. Think about a chess game that has already been played. Imagine that you are replaying that game move by move. As you move through the game, you have the experience of deciding what the next move should be. You think about it, you consider options, you deliberate. But the game has already been played. The next move is already determined. Your deliberation, your sense of choice is happening, but it is not actually choosing. It is following a track that was always there. The feeling of agency is real. The agency is not. Now, you might think that this problem, this contradiction between the block universe and human experience, would have prompted physicists to reconsider some of their assumptions. You might think that when one of the most respected disciplines of science encountered evidence that suggested something fundamentally wrong with how we understand existence, they would treat that evidence with the seriousness it deserves. You would be wrong. Instead, what happened was something more subtle and more insidious. Different fields of physics developed different coping mechanisms for dealing with the problem of time. Quantum mechanics developed one set of responses. Cosmology developed another. String theory developed yet another. And these different fields rarely spoke to each other about the core issue. The result is that today, 100 years after Einstein, 50 years after Wheeler DeWitt, physics as a whole is fractured. Different branches have different answers to the question of what time is, and there is no master framework that brings them all together. Consider quantum mechanics. In quantum mechanics, the situation is even stranger than in general relativity. In quantum mechanics, observation plays a special role. When you measure something, when you observe something, the wave function collapses. The system moves from a state of superposition, where all possibilities exist at once, to a definite outcome, and this collapse happens instantaneously. The measurement is instantaneous. The observation is now. This seems to suggest that there is something special about the present moment, something special about the now. But general relativity says there is nothing special about any particular moment. Every moment is equally real. Every moment is equally present. So how do physicists in quantum mechanics talk about measurement? They talk about it vaguely. They say that measurement is a process that happens at a time. But time is not real. Remember, time is an emergent phenomenon. Time is an effective description. So what does it mean to say that measurement happens at a time? The answer is that nobody knows. And everybody in quantum mechanics knows that nobody knows, but they do not talk about it. String theory has a different approach. String theory is built on the idea that particles are not fundamental. The fundamental objects are strings, tiny one-dimensional objects that vibrate in a space with many more than 4 dimensions. String theory requires 10 dimensions of space and 1 of time to work mathematically, so it assumes that time is one of the 10 or 11 dimensions of the universe. But this contradicts the block universe. In the block universe, there is no preferred direction for time. But in string theory, time is treated as special, different from the other dimensions. String theorists have developed elaborate mathematical frameworks to avoid this contradiction. But the contradiction is still there, sitting under the surface. Cosmology is perhaps the field that has been most forced to confront the problem of time. Cosmologists study the entire universe. They want to understand how the universe began and how it will end. But if the Wheeler DeWitt equation is correct, then the universe does not have a beginning and an end. The universe does not have a history. The universe simply is. It is a static four-dimensional object. It is the block. So cosmologists have invented the concept of the initial conditions of the universe. They say that the universe began in a very special state, a state of low entropy, a state of high order. And from that special beginning, the universe evolved according to physical laws toward a state of higher entropy. But this raises a question that is deeply uncomfortable for cosmologists. If the universe began in a very special ordered state, then why? What caused that initial condition? What determined that the universe would start the way it started? The answer that physics gives is, we do not know. We can describe the initial conditions mathematically. We can write down the equations that describe how the universe evolves from those initial conditions. But we cannot explain why the initial conditions are what they are. This is the cosmic coincidence problem. The universe began in a state that was extraordinarily unlikely. The odds against the universe being as ordered as it is at the beginning are staggeringly large. It is as if someone threw a trillion dice and they all came up with the same number. The probability is nearly zero. Yet here we are. The initial conditions of the universe were exactly as unlikely as they needed to be for life to eventually exist. And physicists have essentially given up trying to explain this. Some physicists have invoked the anthropic principle. They say that we should not be surprised that the initial conditions of the universe are special, because we would not exist if they were not special. We could only be observing a universe in which the initial conditions are special because otherwise we would not be here to observe it. This is technically true, but it is also a form of giving up. It is saying that we do not need to explain the initial conditions. We just need to accept them as a given fact about our universe. Other physicists have invoked the multiverse. They say that there are an infinite number of universes, each with different initial conditions. In most of them, the initial conditions are boring and nothing interesting happens. But in a tiny fraction of them, the initial conditions are special, and life can emerge. We happen to be in one of those universes. We happen to be in a universe where things worked out. Again, this is technically possible, but it is also a way of avoiding the question. It is saying that we cannot explain why our universe has the initial conditions it has, so we will just invoke an infinite number of other universes. The reason physicists keep doing this, the reason they keep invoking principles and multiverse ideas that cannot be tested or proven, is because they are deeply uncomfortable with the implications of timelessness. If the universe is truly timeless, if all moments are equally real, then the initial conditions of the universe are not special, they are just one part of the block. They are no more special than the final conditions of the universe. They are no more special than any other moment. The universe is not evolving from an initial state to a final state. The universe simply is. But people have built their entire understanding of the universe on the idea that the universe is evolving, that it is progressing from the past toward the future, that there was a beginning and there will be an end. The idea that the universe is static, that all moments are equally real, that time does not flow, contradicts something very deep in how physicists think about reality. And so they have responded to this contradiction by inventing new frameworks and new principles to make time come back. They have not said, the equations are telling us that time does not exist. Maybe we should accept that. Instead, they have said, the equations are telling us something that cannot be right. Let us find a way to make them say something different. This is what the institutional response looks like. This is what happens when the deepest equations of physics point toward a conclusion that society is not ready to accept. The institutions do not say the conclusion out loud. They just quietly invent new mathematics to cover up the conclusion. They keep working as if the conclusion is not real. and they hope that eventually some new insight will come along that makes the whole problem go away. But the problem is not going away. The Wheeler DeWitt equation has not been solved in 50 years. The problem of time in quantum gravity is still unsolved. And the reason it is unsolved is that physicists are trying to solve the wrong problem. They are trying to put time back into an equation that fundamentally does not have time. They are trying to make time fundamental when the mathematics is telling them that time is emergent. They are trying to have it both ways. And you know what? Maybe you can have it both ways. Maybe the answer is that both things are true. Maybe time is both fundamental and emergent. Maybe the block is real at the deepest level, but time is a useful and meaningful description at the level at which human beings exist. Maybe the universe is timeless in the abstract mathematical sense, but it is full of time in the lived experiential sense. Maybe there is no contradiction because the two descriptions are just describing different aspects of the same reality. But this answer, while comforting, is intellectually dishonest. It is using the existence of two different levels of description to avoid making a choice between them. It is using emergence as a magic word to make the problem disappear without actually solving it. It is the institutional response taken to its logical conclusion. Because the real question is not whether time can be emergent. The real question is whether emergence is enough. If time is emergent, if it is something that appears when you look at the universe in a certain way, but it is not fundamental, then is it real? Is time real if it only exists for beings who are far enough away from the fundamental equations that they cannot see the timelessness underneath? Is time real if it only exists because of how our brains work, how we construct memories and anticipations? Some philosophers would say yes. They would say that reality is made up of all the different levels of description, from the fundamental to the emergent. They would say that time is real at the level at which it exists. They would say that the fact that time is emergent does not make it less real. But other philosophers and some physicists would say no. They would say that if time is emergent, if it only appears because of how we construct it, then time is not part of the deep structure of reality. Time is a useful fiction. Time is something that the brain creates. Time is not real in the fundamental sense. And this disagreement, this fundamental disagreement about what is real and what is not, is the thing that physicists do not want to talk about, because it is not a disagreement that can be solved by getting more data or writing better equations. It is a disagreement about the nature of reality itself. It is a philosophical question disguised as a physics question, and physicists do not want to admit that physics has bumped up against philosophy. They want to believe that physics can answer all the important questions. But it cannot. At some point, you have to make a choice. And the choice is not between two different equations. The choice is between two different ways of being alive. Some philosophers and physicists have tried to rescue free will by saying that free will just means doing what you want to do, rather than being able to want something different. They say that even in a block universe, your choices are free as long as they are authentically yours, as long as they flow from your own desires and values. But this is a word game. This is philosophy pretending to be something other than philosophy. In the block universe, your desires and values are also fixed. They are also written into the geometry of space-time. You are not free to choose different values. Your values are part of your fixed configuration. So this rescue attempt fails. It does not make anything better. It just makes you feel better for a moment before you realize it does not work. Why is it that physicists, when they sit down at a dinner table with people who are not physicists, tend to go quiet when someone asks them what they actually believe about time? Why do they change the subject? Why do they seem uncomfortable? It is because they have looked into this abyss. They have seen what the equations are actually saying. And they have realized that if they actually spoke out loud about what relativity and quantum mechanics imply about the nature of time and choice and agency, they would be saying something that most human beings have built their entire lives around the assumption of being false. You have structured your life around the idea that the future is open. Every decision you have made, every value you have committed to, every promise you have kept or broken, every moment you have worked to change your life or the lives of others, all of it has been structured around the implicit assumption that the future was not yet written, that you could make a difference, that what you do matters in a way that goes beyond just playing out a predetermined track. The physics establishment has decided quietly not to say this out loud to the general public, not to explain what the block universe actually means, not to translate Einstein's letter into language that a teenager could understand. Why would they do this? Why would they keep this knowledge to themselves? There are a few theories. One is that they genuinely believe that society could not function if everyone internalized the block universe. They think that if most people understood that the future was fixed, that their choices did not matter in the way they thought they mattered, that nothing they did could change what was going to happen anyway, then most people would stop trying. They would stop working, they would stop caring, they would become nihilistic and depressed. Maybe they are right. Maybe the illusion of free will is what keeps civilization running. Another theory is that they do not actually believe it themselves, that despite what the equations seem to say, they have an intuitive sense that time flows, that the future is real in a different way than the past, that human agency is meaningful, and so they tell themselves that the equations are not meant to be taken literally at the metaphysical level, that the block universe is just a useful mathematical formalism, a way of solving equations, not a description of what reality actually is. This is comforting but probably not honest. The equations do not care about your comfort. A third theory is that they genuinely do not know what to do about it, that they are not equipped as physicists to handle the philosophical implications, that the question, what does the Wheeler DeWitt equation actually tell us about reality, is a question that physics cannot answer because it is a question about the nature of existence itself. And physics is built on the assumption that it can only answer questions about how the universe behaves, not why it behaves, not what it ultimately is. So they do what institutions do when confronted with unsolvable problems. They do nothing, but the deeper you dig, the more evidence there is that the physicists have known the answer for 100 years, and they have chosen to remain silent. Here is what I mean. Wheeler and DeWitt published their equation in 1967, within months. Anyone who understood quantum mechanics and general relativity should have been able to see that the equation had no time in it. This was not something that took years to figure out. This was not something that required new observations or new insights. It was just there, obvious, as soon as the equation was written down. The universe, when described by fundamental quantum mechanical laws, does not have a time variable. The universe is timeless. Instead of treating this as the revolutionary discovery it obviously was, the physics community set about fixing it, not fixing our understanding of it, fixing the equation to make it have time in it. Within a few years, physicists had invented multiple frameworks, different ways of interpreting the Wheeler DeWitt equation such that time would emerge. The Hartle-Hawking no-boundary proposal, the tunneling wave function, various other approaches. Each one was a different way of saying the equation does not have time in it, but if we interpret it this way, we can make time appear. Think about how strange this is. Imagine a geologist finds a strange rock formation. She studies it carefully. She eventually determines that the rock formation cannot possibly have formed in the way everyone assumed it formed. It is impossible given the laws of geology. So instead of announcing this discovery and revising the theory of geology, she invents a series of alternative explanations. She proposes mechanisms that no one has ever observed in order to make her data fit the existing theory. She publishes papers explaining how the rock formation might have formed through these speculative mechanisms. And when other geologists ask her why she is inventing new mechanisms instead of just accepting what the evidence shows, she says, well, the evidence is hard to interpret. The traditional explanation is probably still correct. We just need to be more sophisticated about how we understand it. No one would accept this from a geologist. We would say she was engaged in motivated reasoning. We would say she was protecting a theory that her data had falsified. But this is exactly what physics has done with the Wheeler DeWitt equation. The equation shows that the universe is timeless. The physics community has responded by inventing mechanisms by which time can emerge, always careful to say that the fundamental level is timeless, but the emergent level, the level at which we live, has time. This is not being honest about your data. This is running away from your data. Julian Barbour has not run away. Since the 1980s, he has been publishing papers arguing for a timeless universe, not as an interpretation of quantum mechanics, but as a fundamental feature of reality. He argues that the problem of time in quantum gravity is not a problem at all. It is not something that needs to be fixed. It is something that needs to be understood. The universe is timeless. The equations that describe the universe have no time variable because the universe does not have time. Time is not an illusion in the sense that it does not exist. Time is a useful concept that emerges when you have conscious beings with memories and anticipations living inside a timeless block. The response to Barbour from the mainstream physics community has been muted. Some physicists, like Lee Smolin, have argued against him directly. Smolin has built much of his career on the idea that time is the most real thing there is, that the block universe is mistaken, that there is a preferred direction for time, that the future is genuinely open and not yet written. But notice what Smolin has not done. He has not published an equation that describes the universe and includes a time variable in a clean, natural way. He has not shown that time can be fundamental without contradicting the Wheeler DeWitt equation. He has produced philosophy. He has produced arguments. But the mathematics, the deep mathematics that physicists are supposed to trust, keeps coming back the same way every time. Sean Carroll, another prominent physicist and popular science writer, has said that the timeless view does not match the way we experience the world. That time must be real because we experience time. But again, Carroll has not addressed the mathematics. The mathematics does not care about how we experience things. The mathematics says the universe is timeless. Carroll's response is to say that even if that is what the mathematics says, it must be wrong because it does not match our intuition. But intuition is often wrong. Intuition says that the sun moves around the earth. Intuition says that time flows. Intuition says that two events that are simultaneous for me are simultaneous for everyone. Intuition has been wrong about all of these things. So why should we trust intuition when it tells us that the mathematics must be mistaken about time? The math keeps saying the same thing: static, frozen, timeless, and physicists keep looking away. Now I want to introduce one more piece of this puzzle, because it gets stranger. In some interpretations of quantum mechanics, every possible outcome of every quantum event actually happens. This is the many worlds interpretation. Every time a quantum event has multiple possible outcomes, the universe branches into multiple versions, one for each outcome. You are in one branch right now. But there are other branches where you made different choices, where different events occurred, where reality unfolded in different ways. Now combine this with Barbour's Platonia. Combine the idea that the universe is a timeless collection of all possible configurations with the idea that in quantum mechanics all possible outcomes are real. What do you get? You get a picture of reality in which every version of you that could possibly exist is sitting in the block right now. The version that took the job you turned down. The version that married the person you did not marry. The version that moved to the city you decided not to move to. The version that never had the accident that changed your life. The version that studied a different subject, made different friends, held different values. The version of you that died at 6. The version that lived to 110. The version that never fell in love. The version that had the family you wanted. The version that sacrificed everything for their career. The version that sacrificed everything for their family. The version that traveled the world. The version that never left their hometown. All of them. Equally real. Equally frozen. In Platonia. Equally permanent. What does it mean to exist in a world where every possible version of you is equally real? What does it mean to know that somewhere in the structure of all possible configurations, The version of you that made better choices than you actually made is as real as the version that made worse choices. What does it mean that the version of you that is happier than you currently are is not a fantasy, not a dream, not something that is impossible? It is real. It exists. It is frozen in a particular moment of Platonian space, just as real as the version of you that is sad or regretful or lonely. This is where the story crosses a line. Up until this point, we have been talking about physics. We have been talking about equations and mathematical structures and interpretations of relativity. But this question, what does it mean that all possible versions of us are equally real? This is not physics anymore. This is something darker. Because if all possible versions of you are equally real, then what makes you you? What is the difference between the version of you that exists in one configuration and the version that exists in another? In Platonia, they are all the same person. You are not a single thread running through time. You are a set of possibilities, all of them equally real, all of them occupying different regions of the space of all possible configurations. The boundaries between different versions of you are artificial. They are drawn by conscious experience. But conscious experience is what time creates. Conscious experience is the illusion. Some physicists, when pressed very hard about this, will admit that they do not have a clean answer to the question of consciousness. They will mumble something about consciousness being a sequence of brain states correlated with positions in the block. They will say that the feeling of flow is something that brains manufacture from memory and anticipation. They will say that the sense of continuous self, the sense that you are the same person as the version of you 5 minutes ago, is something your brain constructs based on memory and prediction of the immediate future. All of this is technically true. Your brain does construct these things. Memory and anticipation are what create the illusion of a flowing, continuous self. But the question remains. If the self is constructed from memory and anticipation are features of a physical system in a timeless block, then what is the part of the physical system that is conscious of the memory and anticipation? What is the experiencer? What is the part of you that feels like you are moving through the block? This is the most important question that physics cannot answer. This is the question that keeps physicists quiet at dinner tables. Because if the block is fundamental, if the Wheeler DeWitt equation is telling us the truth about the universe, then there is a serious problem. The problem is that conscious experience seems to require a present moment. Conscious experience seems to require that some moments are happening now, are real in a different way than other moments. But the block universe denies that there is anything special about any particular moment. All moments are equally real, equally frozen, equally permanent. How can there be conscious experience without a present moment? How can there be the feeling of experiencing without a now? Nobody knows. And the fact that nobody knows is the thing that physicists do not want to talk about. They have an equation that tells them the universe is timeless. They have a framework that explains why time appears to flow even though it does not. They have interpretations of quantum mechanics that show how multiple possibilities can all be real. But they do not have an explanation for consciousness. They do not have an explanation for the experiencer. And more than 100 years after Einstein unified space and time, more than 50 years after the Wheeler DeWitt equation was written, they are no closer to an answer. Maybe it is because consciousness cannot be explained by physics. Maybe consciousness is something fundamental, something irreducible, something that physics cannot touch. Some physicists have suggested this. They say that consciousness is a feature of reality that is just as fundamental as space and time, and that physics will never explain it because physics only works with matter and energy and quantum fields, and consciousness is something else. Other physicists say that consciousness is entirely explained by the physical brain, and that once neuroscience advances far enough, we will be able to explain the subjective feeling of experience in purely physical terms. But neuroscience is not advancing fast enough for this explanation. And more importantly, neuroscience is not saying what physicists want it to say. The more we understand the brain, the more mysterious consciousness becomes, not less. But there is a third possibility. There is a possibility that the reason physicists cannot explain consciousness is that they are asking the wrong question. They are asking, how does consciousness emerge from the timeless block? But maybe that is not the right question. Maybe the right question is, what role does the timeless block play in creating consciousness? Maybe the reason the Wheeler DeWitt equation has no time in it is not because the universe is fundamentally timeless, but because time is something that conscious observers bring into being. This is not proven. This is not even properly articulated. But it is the kind of question that suggests why physicists might want to keep the block universe quiet. Because if it turns out that consciousness is fundamental to the structure of reality, if it turns out that the universe is timeless until conscious observers arrive to experience it in time, if it turns out that the distinction between the physical and the subjective is not a bug in our understanding, but a feature of reality itself, then everything changes. Physics can no longer stand apart from philosophy. Science can no longer pretend to be objective in the way it has pretended for the last 300 years. This is too much for the established institutions to handle. So they do not handle it. They just keep writing equations that have no time in them and pretending that this is not revolutionary. Now, there is one more layer to this, and it is the most important one to understand. The conspiracy of silence around the block universe is not a conspiracy in the traditional sense. There is no secret meeting where physicists decide to hide the truth. There is no memo. There is no decision that a few people made, and then all the other people agreed to go along with it. The conspiracy is something much larger and much quieter. The conspiracy is built into the structure of academia itself. It is built into the process by which physicists get training, how they get jobs, how they get respect, how they get funding. It is built into the fact that in order to have a successful career as a physicist, you have to be credentialed in the right way, you have to publish in the right journals, you have to work on problems that the establishment has decided are the right problems to work on. Julian Barbour walked away from this system because he understood that the system itself was designed to protect the existing worldview. When a young physicist begins their career, they are trained to solve existing problems. They are taught the equations. They are taught the interpretations of the equations that the establishment prefers. They are not encouraged to ask fundamental questions about what the equations mean. They are encouraged to move on, to solve new problems, to make incremental progress. And if they are smart, if they are ambitious, they will succeed within this system. They will have a good career. They will get tenure, publish papers, train students. But if they start asking questions about what the equations fundamentally mean, if they start pointing out that the Wheeler DeWitt equation has no time in it, if they start arguing that maybe we should take that seriously rather than inventing workarounds, then they are stepping outside the bounds of acceptable scientific discourse. They are becoming a problem. And the way the system solves problems like this is not through direct suppression, it is through subtle pressure. Subtle pressure in the form of rejection letters from journals. Subtle pressure in the form of job search committees who find reasons to hire someone else. Subtle pressure in the form of colleagues who decide that this person is not serious. Subtle pressure in the form of funding agencies that find other projects more promising. The system does not need to consciously suppress this information. The system is designed to ensure that people do not ask these questions in the first place. And if they do ask them, the system has 1,000 small ways of moving them to the margins, of making sure they do not have a platform, of making sure that their ideas do not spread. This is how institutions protect the status quo, not through conspiracy, but through structure. Julian Barbour succeeded in getting his work published, despite not being in the system. Lee Smolin, who is in the system, has written about how he felt pressure to not take Barbour's ideas seriously. Sean Carroll has said things that suggest he is uncomfortable with the implications of the block universe, but he keeps working within it because the mathematics demands it. Other physicists have said in private conversations what they would never say in public. They believe the block universe is correct. They believe time does not exist. But they do not say this out loud because the implications are too much. The implications are too dark. And so we arrive at a point where the deepest equations of physics are telling us something profound about the nature of reality, and the people who understand these equations best have essentially agreed not to talk about it, not formally, not consciously, but effectively. The consensus among physicists is real but invisible. It is not a conspiracy. It is a mutual understanding. It is an agreement to privilege institutional stability over truth. What does this tell us about what it means to be alive? What does it tell us about the value of the choices we make, the people we love, the goals we work toward? If the block universe is real, then you are not moving toward your future. You are contained in a four-dimensional structure that includes your entire life, from birth to death, all at once. Every moment of your existence is equally real, equally present, equally frozen. Your first kiss is not gone. It is not lost to the past. It still exists, unchanged, in the block. You are simply no longer at that coordinate. You have moved to a different coordinate in the block. But the version of you that is experiencing that first kiss still exists, still feels the joy and the nervousness and the wonder exactly as it did the moment it happened. That moment has not passed. You have passed. Your future is not uncertain. The version of you on your deathbed exists right now in the block, in exactly the configuration it will be in when you arrive there. That version of you is as real as the version reading these words. The only difference is that you have not gotten there yet. But the version of you that gets there is already there. And the events that lead to that moment are all already written into the structure of space-time. Does this make the love you feel for another person meaningless? Does it mean that your work is pointless? Does it mean that you should stop caring about what happens next, because what happens next is already determined? This is where the cleverness of the institutional response becomes clear. The institutions have decided that yes, mathematically, the universe is timeless and the future is fixed. But no, this does not require you to change how you live your life. Time is an effective description. The future is effectively open at the scales at which human beings operate. Your choices are effectively free, even if they are not ultimately free. Your loves are effectively real, even if they are ultimately configurations in a timeless block. You can live your life as if time is flowing, as if your choices matter, as if the future is open, because for all practical purposes, this is the best approximation. In other words, the institution is saying, yes, the equations tell us the universe is timeless, but do not worry about it, just keep living as if time is real. This is the most successful form of institutional evasion ever designed. It allows physicists to believe both things at once. They can believe that the universe is timeless, that the block is real, that the future is written. And they can also believe that it is fine to live a human life as if none of this is true. They can maintain their integrity in the institution while secretly doubting everything the institution has been telling them. But this is not stable. This is not healthy. This is a kind of cognitive dissonance that takes a toll over time. It is why physicists go quiet at dinner tables. It is why they seem uncomfortable when someone asks them what they actually believe. They are holding two contradictory ideas and pretending they are compatible. Let me ask you this. If the future is fixed, if every moment of your life is already written into the geometry of space-time, if the version of you that dies is already sitting in the block right now, does it matter what you do? Does it matter what you choose? Does it matter how you love? Does it matter how you work? The answer that the institutions have decided to give you is, no, it does not matter in an ultimate sense. But yes, it matters in a practical sense, so just keep going as if it matters. Keep pushing as if your choices will change the future, even though you now understand that the future cannot change because it is already there. This is not a satisfying answer. This is not an honest answer. This is an answer that allows people to keep functioning while harboring doubts about the fundamental nature of reality. This is what institutional knowledge looks like when it starts to contradict human experience. some physicists have tried a different approach. They have tried to argue that the timeless view does not necessarily mean the future is fixed. They have introduced concepts like the growing block universe, where the present is real and growing, and the block expands as new moments become actual. But this has its own problems. If time is not a dimension, if it is not part of the fabric of space-time, then how can the block be growing? Growing at what rate? Growing according to what clock? Other physicists have argued that we need to take quantum mechanics more seriously than we take relativity, that in quantum mechanics, observation plays a special role, and that this observation must happen in the present moment, in the now. So the present moment must be special in some way that relativity does not capture. But this is just philosophy again. This is not new equations. This is not mathematics that physicists are willing to stake their careers on. The mathematical structure of reality, as revealed by the Wheeler DeWitt equation, seems to be pointing toward a simple conclusion. The universe does not have a time variable at the fundamental level. The universe is timeless. Time is not a dimension in the way space is. Time is something that emerges. But if time is emergent, then time is not fundamental. And if time is not fundamental, then the future is not emergent. The future is not being created. It already exists. It is part of the block. You are moving through a predetermined structure, and the feeling that you are choosing what happens next is a feature of your consciousness, not a feature of reality. This is what the equations are saying. And physicists have decided not to say this out loud. Why? Why not just tell people? Why not have this conversation in the open, instead of in the quiet halls of universities and the private letters of the dying? Maybe because the institutions are right. Maybe a society that fully internalized this view would collapse. Maybe people need the illusion of free will to function. Maybe the sense that the future is open, that our choices matter in an ultimate sense, is what keeps civilization running. Maybe the comfortable lie is better than the devastating truth. Or maybe we have underestimated the human capacity to hold complicated truths. Maybe people could handle learning that the future is already written and still continue to care about their choices because their choices are part of the writing. Maybe understanding that every moment of your life is frozen in the block would not make you stop loving. It would just change how you love. It would make you appreciate each moment more, understanding that it is permanent, that it will never fade, that it is literally always there. Maybe understanding that the version of you on your deathbed already exists would not make you despair. It would comfort you, knowing that that moment is as real as this moment, that you will not cease to exist, that you will not vanish into nothing. You will simply be there, frozen in that moment the way every other moment of your life is frozen. And the version of you reading these words will be here too, forever, exactly as you are right now. Not suffering, not dying, not ending, just existing perpetually in the structure of space-time. Is that comfort or is that horror? Is that a consolation or a prison? The answer probably depends on what happens between now and then, on whether the moments that get added to the block are moments of love or loneliness, moments of meaning or meaninglessness, moments of connection or isolation. Because if every moment is permanent, if every moment is frozen forever, then the nature of the moments matters. The character of each instant matters. Because that is all you have. That is all anyone has. Not a future that is still being written. Not possibilities that are still being decided. Just moments. Just configurations. Just frozen instances in a vast structure that exists forever. And from that perspective, maybe the physics establishment is not so much lying as they are being kind. Maybe they are protecting people from a view of reality that would make it harder to create meaning and connection. Maybe they understand that the value of living does not come from being able to choose the future. It comes from whatever happens in the present moment, the moment you are in right now, which will always be there, which will always matter, whether or not you know it. But I do not think we should make that choice for people. I do not think institutions should decide what truths people are ready for. I think people deserve to know what the physicists know. I think people deserve to know that the deepest equations of reality, The equations that physicists have refined and tested for 100 years are pointing toward a universe that is fundamentally timeless, that the block is real, that the future is written, that you are not moving forward through time. There is no forward, there is no arrow. There is just an infinite gallery of moments, all of them permanent, all of them real, and your path through them is already complete. Some people will find this liberating, some people will find it crushing, but everyone deserves to know. Everyone deserves to make the choice themselves about what to do with this information. Some people will find this liberating, some people will find it crushing, but everyone deserves to know. Everyone deserves to make the choice themselves about what to do with this information. The implications of timelessness for how we understand death are particularly profound and worth exploring in depth. Most human beings, when they contemplate their own mortality, imagine a kind of vanishing. They imagine themselves living out their life, experiencing moments and memories and connections, and then, at some final moment, ceasing to be. They imagine death as an ending. The end of existence, the point at which I stops existing. The block universe changes this picture completely. In the block universe, your death is not an ending. It is a place, it is a location in space-time. The moment of your death exists just as much as the moment of your birth. It is frozen in the block. It is real. And the version of you that is dying, that is experiencing the last moments before your heart stops or your brain shuts down, that version of you is as permanently real as the version of you that is young and healthy and full of possibility. From the perspective of the block universe, you do not cease to exist at death. You continue to exist exactly as you are in that moment, forever. The block does not change. Moments do not pass. So the version of you on your deathbed will always be on your deathbed, in that particular moment, in that particular place in the four-dimensional structure of space-time. You will never move from that moment, but that moment will always be there. You will always be there. Some people find this comforting. They say that death becomes less frightening when you understand that you do not cease to exist, that you continue to exist in that final moment, permanently. They say that in a sense you are already dead. The version of you that dies is already there. So there is no point in fearing the future, in dreading the moment when you will cease to exist, because that moment is already as real as this one. But other people find this terrifying. They say that the idea of being frozen in a single moment, experiencing the same dying moment forever, with no way to move forward or to escape that moment, is worse than ceasing to exist. They say that at least if death is an ending, if you cease to exist, then the suffering ends. But in the block universe, there is no ending. There is just a freezing of the moment. The version of you that suffers dies suffering permanently. This is one of the great tensions at the heart of the block universe. The block seems to solve the problem of existence. If all moments are real, then you do not vanish. You do not cease to be. In a sense, you are immortal. Your entire life from birth to death is locked into the four-dimensional structure of reality. It will always be there. You cannot die, in the sense that you cannot cease to exist. But this immortality comes at a price. The price is that you also cannot live, in the sense that nothing you do changes anything. Everything you do is already done. Everything that will happen to you is already happening, in a location in space-time that exists even though you are not at that location right now. You are frozen in every moment of your life, permanently. And perhaps more troubling than this is what the block universe tells us about memory. We think of memory as a way of preserving the past. We think that when we remember something, we are accessing something that is real, something that still exists, something that happened to us. But in the block universe, memory is something different. Memory is a correlation between your present brain state and your past brain state. It is information stored in the physical configuration of your neurons, information about what happened at some earlier coordinate in spacetime. But the earlier coordinate is just as real as the present coordinate. And the information stored in your memory is not a copy of the past. It is not a recording of what happened. It is just a physical correlation. The actual event that you remember is still happening at its coordinate in spacetime. The version of you that experienced the event is still there, still experiencing it. Your memory is not accessing that version of you. Your memory is creating a neural state in your present brain that resembles the neural state that existed in the past. So when you remember something, when you relive a memory, you are not actually connecting to the past. You are creating a current brain state that resembles a past brain state. But the past brain state is not gone. It is not accessible. It is just there at a different coordinate in the block, frozen, unchanged. This has profound implications for the way we understand personal identity and continuity of self. We tend to think that we are continuous beings that persist through time, that the person you are now is the same person as the person you were 10 years ago, connected by a chain of memories and continuous experience. But in the block universe, this continuity is an illusion. The person you are now is a different configuration than the person you were 10 years ago. There is no actual continuity. There is just two different configurations at two different coordinates in the block, and your present brain has a memory of the past configuration. The sense that you are a continuous being, that you have a life that extends from birth to death, that you are the same you throughout that life, is something your brain constructs. It is a narrative that your brain creates, a story that it tells about the relationship between your past and your present. But the narrative is not real. The story is not true. You are not actually a single being that persists through time. You are a set of different configurations, all of them equally real, all of them equally permanent, all of them you, but not connected by any actual temporal flow. Some physicists have suggested that personal identity in the block universe might actually be even stranger than this. They have suggested that if many worlds quantum mechanics is correct, if all possible outcomes of quantum events actually happen, then every version of you that could possibly exist is real. And each version is you. The version that made better choices than you made is you. The version that made worse choices is you. The version that never was born is you. Think about what this means. The you that you are right now is not the only you. In fact, you are not singular at all. You are plural. You are a multitude. You are infinite versions, all of them equally real, all of them equally you, existing in different branches of the quantum wave function, or in different regions of Platonia. In what sense are you singular? In what sense are you one being rather than many? The answer, if this interpretation of quantum mechanics is correct, is that you are not singular, you are not one being, you are many beings. And each version experiences its own life, its own sequence of moments, its own sense of continuous self flowing through time. But from the perspective of the block, from the perspective of someone standing outside the structure and looking at all possible configurations at once, you are not one being with one life. You are infinite beings with infinite lives. This is the kind of realization that can break someone's mind if they sit with it too long, because it means that the sense of being a single, unified self with a single life is even more of an illusion than the block universe already implied. You are not one. You are many. And each version of you is equally real, equally permanent, equally you. Next time you talk to a physicist, if you ask them about time, if you really press them, watch what happens. Watch their expression. Watch them search for words. Watch them try to figure out how to be honest without admitting what they know. That pause, that moment of discomfort, that is the conspiracy admitting itself. That is the moment where the institutional silence is visible. That is where you can see the burden they carry. The burden of understanding something that the rest of society has decided not to discuss. The burden of knowing that the future is not open and not being able to say that out loud. And then you can make your own choice. You can look at the equations yourself. You can read Barbour's work. You can read Einstein's letter. You can sit with the idea that the block is real and see what happens to your sense of meaning, your sense of choice, your sense of self. You can decide for yourself what to believe, rather than letting the institutions decide for you. That is the only honest thing to do. But I want to take this further. I want to talk about what would happen to civilization if people actually accepted the block universe. If people actually believed, with full conviction, that time does not flow, that the future is already written, that their choices are predetermined, what would change? Some people argue that nothing would change. They argue that even if you believe that the future is already written, you still have to make choices. You still have to navigate uncertainty. You still have to figure out what you want and work toward it. And in a practical sense, this is true. Knowledge of the block universe would not eliminate the need to make decisions or to work toward goals. But other people argue that something fundamental would change. They argue that the motivation for making good choices, for working hard, for trying to improve yourself or the world, comes from the belief that the future is open. It comes from the belief that your choices matter, that you can change things, that the future depends on what you do right now. And if you stop believing that, if you accept that the future is already written, then the motivation disappears. Why work hard for a goal if that goal is already determined? Why try to make the world better if the world will be exactly as it is meant to be, regardless of what you do? This is the fear that has kept the block universe quiet. This is the fear that has kept physicists silent. This is the fear that has led the institutions to decide that the public cannot handle this knowledge. And it is a real fear. There is something plausible about it. There is something in human nature that responds to the belief in open possibility. There is something in human beings that needs to feel that the future is undetermined, that their choices matter, that they can make a difference. But I think this fear is misplaced. I think it is based on a misunderstanding of what the block universe actually implies. Because accepting the block universe does not mean accepting that nothing matters. It means accepting that the mattering is not temporal. It means accepting that value and meaning are not located in the future. They are located in the present moment, the moment you are in right now. Think about it this way. In the block universe, every moment of your life is equally real. Every moment is equally permanent. Every moment is equally valuable, in the sense that every moment equally exists. So the meaning of your life is not something that is determined by whether you achieve your goals or accomplish your dreams. The meaning of your life is determined by the quality of the moments that constitute your life. Are they moments of connection or isolation? Moments of understanding or confusion? Moments of joy or suffering? Moments of growth or stagnation? If the future is already written, if all moments are already fixed, then the value of your life is not dependent on what you accomplish. It is dependent on what you experience right now, in this moment. The value of your life is determined by the character of the moments that make up your life. This is a profoundly different way of thinking about meaning and purpose. It is a way of thinking that says that the value of your life is not something that you achieve. The value of your life is something that you live. And you live it right now, in this moment, and in the next moment, and in the moment after that. Each moment has its own value. Each moment is its own complete experience. If you could actually accept this, if you could actually internalize the block universe and all that it implies, then something might shift in how you approach living. You might stop worrying so much about the future. You might stop deferring your happiness, deferring your connections, deferring your experience of joy to some future moment when you have achieved enough or accomplished enough. You might start paying attention to the present moment, understanding that this moment is real, that it is permanent, that it will always be a part of your existence. You might start making choices not because they will change the future, but because they are the right choices to make right now. You might work toward goals not because you need to achieve them to matter, but because the process of working toward them, the actual effort and struggle and growth that happens along the way, is itself meaningful. You might love people not because love is a means to some future happiness, but because loving them right now in this moment is valuable in itself. In other words, accepting the block universe might lead not to nihilism but to a kind of radical presence. It might lead to paying attention to what is actually happening instead of being distracted by what might happen. It might lead to appreciating the richness of lived experience instead of being anxious about the future. But this is not what the institutions think will happen. The institutions think that if people accept the block universe, they will become depressed and nihilistic. They will stop trying. They will stop caring. And maybe they are right for some people. Maybe for some people the belief in open possibility is necessary for functioning. But is it really necessary? Is it necessary to lie to people about the nature of reality in order to keep them functioning? Is it right to decide from the top of an institutional hierarchy that the public is not ready for certain truths? I do not think so. I think people are capable of handling difficult truths. I think people are capable of understanding that the future is already written and still finding meaning in the present moment. I think people are capable of accepting the block universe and still caring about their choices and their lives. But this would require a fundamental shift in how we think about meaning and value. It would require letting go of the idea that the future is what matters. It would require believing that the present moment is what matters. And this is terrifying for people who have built their entire lives around achieving things, around accomplishing goals, around moving toward a better future. This is the real conspiracy, the real collusion between the institutions and the public to avoid thinking about certain truths. It is not a conspiracy to suppress information. It is a conspiracy to avoid changing how we live. It is a mutual agreement to keep pretending that the future matters more than the present, that what we accomplish matters more than how we experience what we are doing, that we are progressing toward something rather than living in something. And maybe that conspiracy is necessary. Maybe societies function better when people are focused on the future, when people are trying to achieve things, when people believe that change is possible. Maybe the illusion of progress is what keeps civilization running. But if that is true, if that is actually what is happening, then it should be acknowledged. It should be said out loud. We should say, yes, we know the universe is timeless. Yes, we know the equations tell us that the future is fixed. But we are going to pretend that it is not, because we think it is better for society if we do. We are going to teach people to believe in progress and change, even though we know, at the deepest level, that there is no progress and no change. We are going to make the comfortable lie the foundation of civilization, and then we should ask whether that is right, whether that is good, whether that is the best we can do. Because the alternative is not necessarily worse. The alternative is to accept the block universe and to build a civilization on the foundation of present moment awareness instead of future-directed progress. It would be a different kind of civilization. It would have different values. It would measure success differently. It would understand meaning differently. But it might not be worse. It might be better. Imagine a civilization that has accepted the block universe. In such a civilization, people would not be constantly anxious about the future. They would not be constantly trying to achieve things, constantly postponing their happiness, constantly deferring their connections to some future time when they have accomplished enough. Instead, they would be focused on the quality of the moments they are living right now. In such a civilization, work would be valued not because it leads to future achievements, but because the work itself is meaningful. Education would be valued not because it leads to future success, but because learning is intrinsically valuable. Relationships would be valued not because they lead to future happiness, but because the connection itself, right now, is valuable. In such a civilization, there would be less stress and anxiety, because people would not be constantly worried about whether they are progressing fast enough. There would be less depression, because people would not be constantly comparing themselves to an ideal future self that they are trying to become. There would be more appreciation for beauty, because people would not be so distracted by goals and achievements that they miss the beauty that is in front of them right now. Would such a civilization be more or less productive? That is hard to say. On one hand, people might not work as hard if they were not motivated by future achievement. On the other hand, people might work better, with more joy and engagement, if they were focused on the quality of the work itself rather than on future outcomes. Would such a civilization be more or less happy? Again, hard to say, but my intuition is that it would be happier, because happiness is a property of present moments, not future achievements. And if people were focused on the quality of present moments, they would be happier. But this is all speculation. The block universe is not a practical philosophy. It is a fact about the nature of reality. It is something that has been revealed by the deepest equations of physics. And the institutions have decided to keep this fact quiet, to keep it away from the general public, to let people continue to live under the illusion that the future matters more than the present. And I do not think that is right. I think people deserve to know what the physics establishment knows. I think people deserve to have the choice of whether to accept the block universe or to reject it. I think people deserve to be treated as adults capable of handling difficult truths. Because if the block universe is real, if every moment of your existence is permanent, then this moment, the moment you are in right now, reading these words, considering these ideas, this moment is as real and as permanent as any other. This moment matters, and it will always matter. Not because the future might depend on it, not because your choice right now will change what happens next, but because this moment is already part of the block. This moment is already permanent. This moment is already you, and you exist right now, forever, in the frozen gallery of all that has ever been and all that will ever be. Make it count.